Okay, so we're going to finish up chapter 18. We're talking about shore effects. So as the waves come into shore, you're going to have different types of waves. So you can see here you have a deep water wave, crest, the trough. Then you'll have the surf zone breaker, and then the beach. So the breakers are at depths less than the water height. The lower part slows and the top part breaks forward. So in the surf, this is where basically it's kind of like you're walking down the street and all of a sudden you kind of lose balance and your head starts going first and your feet kind of don't catch up, and so you topple over and your head goes first. And that's what happens with waves. As they're coming in, the top part becomes heavier, falls over, and creates this surf, this breaker zone, which is what people try to surf on, okay? And you can see them here as the waves topple over, they form these really nice white caps. So another type of shore effect we're going to talk about is when water that's transported toward the shore by the breaker must return. Okay, so once it comes in, it has to be able to return out to sea somehow. And it can do that in a couple of different ways. The first way is called the undertow, which is the direct return of water under the breaker. So it basically gets sucked back underneath the wave and then runs back out. And sometimes if you go further enough out, you can get stuck in the undertow, which is pulling you out to sea. And sometimes what happens is you go and you'll see somebody swimming and they'll be, maybe 5 feet away from you, and you'll look later and they're 20 feet away from you, but they themselves think they haven't moved. And that's because the undertow has been slowly pulling them out to sea. So they'll tell you in the beach when there's a really strong undertow to be careful so that weak swimmers do not get pulled out into the ocean. The other type of way that water is returned out is longshore currents. And this, instead of it being out to sea, it's along the shore. So sometimes this is seen as you go to the beach, you set up your camp, your umbrella, your chair, you go out into the water and you're playing around, and then you look up and you've been moved down shore about 50 feet. And so your umbrella is now really far away and you're looking at somebody else's umbrella. And that's the longshore current. It's moving you down the shore, and that's how the water is returning back into the ocean. Now the rip current is going to be a strong stream of water pushing out against the waves. Usually it's going to extend beyond the surf zone and then diminishes. So it's going to be really strong right there along the breaker. And it's indicated by a lack of surf, darker water, and a turbid streak. And so you can see here it's kind of being pulled away from the beach. And so instead of it looking like the waves are coming in, it's going to look like the waves are being pulled out. So ocean currents, there's streams transporting water over large oceanic distances along roughly the same path. And these are our ocean currents. They're produced by two different ways. One is density differences in the seawater, and then winds blowing persistently in the same direction. And these are not going to be small local winds, but large global wind patterns. So the density current is the following. If you look at cold, dense Arctic water, the cold, dense water wants to sink down below. By sinking down below, it's going to push the warmer, dense air up, which then produces a convective-like nature, just like we've been talking about several times. The other type is your global circulation patterns that maintained basically by patterns of the prevailing winds. And prevailing means they're always going to blow in one direction. They're going to be influenced by the rotation of the earth and ocean basin shapes. So looking here at this image, you have the different types of currents indicated by the blue arrows. So if you've ever watched Finding Nemo, he talks about the East Australian current, where they get in there and they basically just ride like they're inner tubing along. And those are the same types of currents we're talking about. There's the Gulf Stream current, the one around Gulf of Mexico. There's some along the east coast and the west coast. Now, a gyre is going to be a great system of water circulation centered in the mid-latitudes, and the direction is dictated by the Coriolis effect. So you can see those around the Peru current, the Brazil, the over the Australia, that they kind of go in the same counterclockwise direction. So there's also going to be a thermohaline circulation based on the warmth and the cool And this is the global ocean circulation, which essentially connects all of our oceans, even though they have different names and they have different features, whether they're cold or hot, they're all going to be interconnected. All right, so the ocean floor. The ocean floor is made up of different regions. The continental shelf is the part that we tend to be on when we go to the beach. It's the eroded continental margins, relatively shallow water. The continental slope is the steeper transition feature beyond the continental shelf. So you can see here it slopes off. It's often cut by submarine canyons, so underwater canyons. The ocean basin is the deepest part of the ocean, characterized by practically level abyssal plains and mountainous ridges. So you see those here, the plain and the ridges, which are like underwater mountains. There are usually trenches along the ocean basin edges. Remember, we talked about why that would be the case when we talked about plate tectonics. And then you have volcanic peaks occasionally forming scattered seamounts like the Hawaiian Islands or the Aleutian Islands. So that's going to end chapter 18. Make sure you submit your notes when you are done. And the next chapter will be chapter 20 because we skipped chapter 19. So just make sure you are